In this presentation, we will be discussing design of experiments. The main elements of a DOE include explanatory factors, response variables, treatments, experimental units, a method of randomization and blocking, and a designated sample size and number of replications to perform for the design. To create and perform a DOE, we have analyzing factors to see which ones have the biggest impact. A design may be created to determine what factor is causing defects in a manufacturing facility, or it may be needed for optimization, such as finding the best combination of ingredients or factors, such as popcorn. And this is an example of maximization. Performing experiments can be very expensive, so it is best to find one factor that is important to test instead of testing them all, wasting time and resources. When performing the experiments, we must have the data from the design experiments to back up that it is worth putting the extra time and money into performing the experiment. For our example using JUMP, we use the popcorn dataset. The underlying model is quadratic. For popcorn data, we are optimizing, so we are maximizing the total number of kernels popped. This is a response surface method DOE. We are also using a proportion because it is the total kernels popped over total kernels.
The purpose of a design of experiments is to determine the relationship between factors affecting a process and the output of the processes. This finds the cause and effect relationships. The response surface method, or RSM, is a DOE, and it's typically used for optimization. The underlying model is quadratic. In order to optimize using the RSM, we use the DOE Create DOE tool in JUMP. The prediction variance is relative to the error variance. When the relative prediction variance is 1, the absolute variance is equal to the error variance of the regression model.